Okay, testing, testing. Well, that one's doing something. Okay, maybe it's working. I don't know. Okay, welcome to Programming Rainbow. I will be talking about the shell game in this video. So I'm not sure if everything's working. Having problems with the internet. So see if we have some good luck. Okay. So we're going to be talking about shell games. So this is a bridge for making 2D games or however you want to, 2D games, SDL games in Bash or ZSH. So this is tested on Linux and in Mac OS. So if you have a Windows machine, you made a bad decision. And let's get started. So I just kind of want to show it working. So I'm going to do that. So if you clone this, let's back up here for a quick second. If you go to github.com, Programming Rainbow, this is called ShellGame SDL2. There is only an SDL2 version right now because of the state of SDL3, but there can be an SDL3 version. It's just because of it's not ready yet. SDL3, not my system, but SDL3 people are not ready with their, they haven't got their act together yet and their system is not finished. So right now this is SDL2. But you can clone this repository. There is some instructions for Arch Linux and for Mac OS. There is, if you're on a different Linux system, you figure it out. It's not complicated. There is also an explanation of all the commands that you can use. Okay, so that is where you can go grab this. This is on GitHub. This is live, and again, this has been tested on Linux, at least for Arch Linux, and on Mac OS on an M3 machine. Okay, so let's take a look at it. There is some examples in here. So this is a framework for you to make your own game, but there's just some examples, some of the things I was just testing while I was programming this, just to make sure stuff works. But there's also my little yellow game thing. I, made sure it's up and running. So let's just look at that. So you can just, from the top level directory, you can just type in minor executable. But if you have just cloned this, it probably doesn't have the executable flag on it. So you could type bash or ZSH, and then it would be examples. And let's look at yellow snow. And so this is going to tell me if I just launch it straight up, there's multiple different backends. So I'm just telling you about this right now. I made it where it's optional. I put an optional switch in my script. If you're making your own project, you do not need to do this. So when I launch this right here, it's going to give me this saying I didn't give it one of the backends. So that's just because of my own work. You don't have to do this. But we're going to use pipe. And see. Okay. So it's saying the server is missing. I haven't compiled the server yet. So if you just got this from GitHub again, you're going to need to compile the backend. So this would be make -c. We need the server. So the server is in SG server right here. So this is SG server, and we can just say release. Now, there is a bug in SDL2 that has been patched, but I don't think it's rolled out yet for Mac OS. So when I compile this on Mac OS, I use very strict compiling rules. And because of the bug that's actually in SDL2, not in my code, it refused to compile. So if you're on Mac OS and you have this problem, just leave off the release and it will compile it without my strict, you won't get optimization. You won't get like O3 and all that stuff, but it will just compile and work. But I want the optimized version and I like to use the strict stuff. So I have a release version and also a debug and a just normal version. So I'm doing release, but on Mac, if you run into this bug, if it's not patched yet, just leave the release off and you'll be fine. Okay, so we're compiling away. It should be done. There it goes. So now let's try that command again. Bash examples yellow snow.sh, running it from the top level and telling it pipe is my backend. And I have messed up here. Let me change the sound over. So now you should have the sound. Sorry about that. Make sure that I'm not listening in on the sound here. It's not listening, and so let's go back to our code and then our game. So we have this game right here. It is an SDL2 window, and it's running the little yellow snow game. And we can see what FPS by pressing F. Right now it's getting like 2000 FPS. It's not really important because the game isn't doing anything right now. So it is flipping over at 2000 times a second, but it's not doing any logic right now. It's just spinning an empty loop because the game is over. So don't worry about that too much. But for me, it was helpful just to know how fast I'm sending and receiving information from Bash to this C server. So this is how the game would look. Yeah. And this is all great. If you've seen this game before, this is the exact same. And we have I'm going to mute the music. We have this don't need the yellow snow up here in the top. We have a little snowflake drawn. We have our window here. It can go full screen, but I'm not going to do that because it'll mess up the stream. So I'm not going to go full screen. But it does if you press, maybe for this one, it's 1 or something. I can't remember. Okay, so that's pretty cool. Again, you'll see the frame rate drop when it's actually playing. Now it's at 800, which is more reasonable. That's still very fast, but again, this game is very simple. So yeah, it doesn't need to be there. So realistically, let's just look at the code, and and by default, it runs at 60 frames a second. So I tried to comment this a lot. So the little thing in the beginning there is this blob right here, which you don't need that. All you really needed to do if you wanted to run the pipe backend would be to source. It's a pipe. It's in the top level, so it is pipe.sh, and maybe put something like here, something like that, or exit 1, just in case it doesn't source properly. And you don't need all this. That can be gone, and this should still work. Let's try it. Bash. I'm trying to do the way that you would do it, not the way that I've been doing it. We'll leave that off now, and we're still working. Okay. And we have some little information here. It's just me. It's telling me that I am in the Bash environment, not ZSH. If you're running in ZSH, you'll see that as well, because if you're on Mac, you might be using ZSH instead. And let's see. Come on. Let me make sure that I'm just wondering if YouTube is actually showing that I'm on. Maybe it's not. Who knows? It's not showing me live right. Okay. It is saying I'm live right now. Okay, cool. Sorry about that. I'm just checking, make sure I'm doing everything right. So there is some information here. It says running in Bash environment. That's just for me. It says I'm using the pipe server. It's actually all the same server, but it's in like the pipe mode, which is the communication is using the named pipe for Unix, which works in both Linux and Mac OS. And here is when I shut down. Basically, it's telling me it's freeing everything that needs to be freed. So when you're writing in Bash, you're not worrying about memory management, but the server is handling all the memory for you. And so this is just messages I did for myself. I might remove them later. I just wanted to make sure things were working correctly. So it's just telling me things are being freed and it's being shut down, and then the server's being shut down. So it's not important information. But I did try to make it friendly debugging messages. So if you do something wrong, it tries to, tell you what went wrong and possibly where it went wrong. So let's kind of look through the code here. This is, like I said, just bash. So we're just doing some global variables right here, like the width and the height of the screen. Player offset, that's just for my collision detection because I want it to be more colliding next to the snowman's head, not the whole snowman itself. The size of the flake, which I populate by actually the size that is loaded in by the image. We'll see that. This is the size I want the text to be. This is the score in the top right hand of the screen. This is where the ground is, the velocity that I want things to move at. These are all just variables for myself. And I'm creating an array of flakes. I'm going to populate this with 15 flakes, which will be the white and the yellow flakes. I'm also creating an associated array for myself for capturing keyboard input, like the escape key, which should be like this. It just bothered me the way it looked. Escape, the F key, space, W, and M. Now, M is muting the music. W is, I put that as for like with the window full screen or not. But again, I don't want to show that because it'll mess up my stream. Space resets the game when you hit a yellow flake, and F is showing the FPS. The F, it's not important to the game, but those are just things I added in there. And I also want to know if these are if a key has been pressed, but I want to know if the state of the left or right key is being held down for this frame, not a pressed action from going up to down, but just held down. So that's a different thing. That's called a held and not a pressed. Again, these have nothing to do with the server. This is just bash side, the way I am deciding to write my bash code. So however you like to write bash code, you can do different things. This is not strictly needed. It's not part of the kind of the bridge or the game server. It's just going to give you back the information. You get to hold it however you want to hold it. And I'm doing the same thing for this flake because I'm going to be grabbing the left, the right, and the center Y all at once. So I'm just kind of holding it into an associated array. Again, you don't have to do this either. This is just styling. Here, I have a function here that's resetting a flake. This is just all bash code except this right down here. This is our first command we see going to the server. So yeah, all the way till here, all this is bash, has nothing to do with the ShellGame server that's running, but this is the first command. So here we're just using random, and I just want the width of the screen minus the width of one of the flakes. The width and the height of the flake is the same size. So I'm getting a random number on that. I also want to know if the game, if it's a full reset or a partial reset. This is just because in the very beginning of the game, I want all flakes to be in above the screen and the size of the screen that is one screen above it. But I actually want that. I want it 2 screens above it. Those flakes are going to fall down and they're going to fill up the screen. So all those flakes will be either on the screen or 1 screen above. And every time I reset, they're going to go to 1 screen above. But in the very beginning of the game, when there's no flakes on the screen, I want them to not all be compact into just the size above the screen. I want them to be 2 screens above the screen. So that's what this is doing. I'm going to height times 2 if it's a 1. So if I send in if I call this function with a 1 as the first parameter, I'm going to do a full reset, basically, like I'm resetting the game. But anytime a flake hits the ground, it needs to reset. That's the normal reset. So that'll be a 0 here. So that's just the way I've programmed this game. This is all bash right here. But here's our very first command. When we've got these X and Y numbers of where a flake should be, now I'm going to set that flake. So, and we haven't seen how the flakes are made yet, but this is a command set, and I'm using a rectangle for these. Set rectangle position. So I want to set the position, which is going to take in an X and a Y. And I'm going to use those 2 numbers that I just figured out. The X here is their X, and the Y here is the Y. And this 2 right here, this function takes 2 parameters. The first one is whether it's a full reset or not. The second parameter is the actual ID of that rectangle that I want to deal with. So that is number 2 here. So that's the ID. So this function right here, if we go over to here, and it's a rect, we're dealing with a rect. So let's just look where, whoops, trying to search for things like I would in NeoVim. So if we just type in rect here, we have a new rect. Let's go down a different rect here. Nope, that's not the one I want. So text objects. I want the one that deals with just any object. So here's updating delta time down here. The size, the rotation, and position properties. These affect sprites, recs, and text objects. So right here, the command I'm using is set, and the type I'm using is a rect. So it's set rect position, and it takes an X and a Y, and then it takes an array of IDs to recs. So you can give it 1 rect or 10 recs or however you want to do it. You can give it a whole bunch of recs, and it's going to set all of those recs internally to what it is. So that is the function that we're using right there. This is just a predefined function. We haven't seen where these recs are coming from yet. The first thing to actually start the game server. So the communication server is already started by this pipe.sh backend. That starts communication. So the server is up and running, but the SDL part of the server is not up and running. So when we go start SG, that gets SDL up and running and gets our window, everything else. Everything's ready. And it gives you a default width and height. It gives you a default title, and it doesn't set an icon, but you can override them. So these right here are overriding them. So this one is the SG is for ShellGame. So set ShellGame title, and everything after the space after title, the entire rest of whatever you put in here is going to be the string. Okay. So set SG title, and whatever string you put after that is going to be the title string. And we can go set SG icon, and this will be the icon for the window now. And we have in examples in the images folder, we have a yellow flake. So I'm setting it to that yellow flake. And we can set the width and the height, although I'm setting it to 800 by 600, which is the default. So for this instance, the window, again, let me just show it to you. I'll just turn these off for a second and you'll see what I'm talking about. So disabling all of these, and let's start up the game. And now it just says bash SDL. I'll probably change this to ShellGame. There's just this X Windows default icon here, and it is 800 by 600. Now, the last one actually just sets it to 800 by 600 by this variable up here, which is pointless. But if you were using a different size, it would be fine. So we have this right here. Let's try to change it to a different size because I can't remember if I made it where I can make it scale itself. So let's say 50% bigger. I actually don't know what's going to happen here. I believe it should scale, but maybe it doesn't. So let's go 800 would be like 1200 and 900 just to make it bigger. And I think the window should scale, but maybe nothing happens. Maybe it crashes. Who knows? And it didn't do what I wanted it to do. Part of it is, but it didn't scale the window. Does the snowman go all the way off? Okay, interesting. Yeah. So I didn't scale the kind of logical space. So yeah, that's something I could work on. I can make it where you can have a window, because I've hard coded where the ground is and everything else, and then you can just scale it. But if you go into full screen mode, this does work correctly. It takes this window size with all the mechanics of it, and it does it full screen. The only problem is it messes up the streaming, the FFmpeg that I'm using right now. So I might look into this later. I don't know. It's not really important because I've chosen to use that size wallpaper and everything else, but you could stretch it and do other things. So 800. Sorry, this is 800 and this is 600. So that's what these are doing. These are overriding. You don't need to do these. They're optional. I am loading the background image as a sprite. So when I say sprite, that means I get an image and a rectangle wrapped into one. So I don't have to think about dealing with a rectangle. It's already part of the sprite, and everything that I can do with a rectangle, I can do with a sprite. And what happens is it's for like a single rectangle image. So, or sorry, it's I'm using the entire size. So this would be the same in SDL if you were to use null as the source rectangle, and then you had a destination rectangle. That's what I'm doing here. I'm wrapping it up in one object. So when I say new sprite and then I give it an image, it creates a new image. It loads it up to me, puts it into the sprite object in memory for me in my server. It's handling all the memory management for me. And it also creates a rectangle as part of that, and it populates the width and the height of the rectangle for that image. So it returns me an ID back, which gets returned as this global reply. And anytime I'm getting a single thing back from new or get, it's going to be populated in reply. So I'm saving it as player. So this player variable is holding an ID to the sprite. So anytime I want to do anything to this sprite, I'm going to use this player variable right here for its ID. Okay. So I've loaded a sprite. Now I can do anything that I want to do with a sprite. I can set it to a location. I can make it bigger, smaller. I can rotate it. I can flip it horizontally, vertically. I can tell it to draw itself. I can do all kinds of stuff. So right here, what I'm going to do is I'm going to set the bottom. So for the recs, I've used X, Y, T, B, W, H, CX, CY, and then I've also done top, bottom, left, right, and obviously right, left, L, left, and X are all the same, but it's like you get to choose which one you want to use. So right here, I'm setting the sprites B, which is bottom, or I could have wrote the word bottom, to ground, which is a variable I set up here, which is like 535. Yeah. I'm just saying, hey, I want the bottom of this sprite to be at that spot. So I don't have to think of where the top is and add the height to it. I don't have to do all that stuff. I can just say set the bottom there. So set the bottom to ground, and this is the ID of the sprite. So this is the variable for ground. This is the ID of the sprite. If I wanted to set 2 sprites to the same exact bottom position, or 100 or whatever, I could just keep adding them here, or I could drop in an array that is expanded to a space separated list, or however you want to say it in Bash, and it would do it to all of them. So this is setting the bottom. And now I'm getting where the top is, because since I set the bottom here, I don't want to do the math myself and know where the top of the sprite is. So I'm just saying, hey, where is the top of the sprite? So I could do a get sprite T, or I could use top or Y would have worked as well. And I put in the ID of the sprite, it populates my reply, and now I have my player top variable set. So I could just echo these out and we could see. And I'll just echo it out here. I should have made it better, actually. I should have said top is. So you can kind of visually see what's happening here. Okay, so we'll just run it real quick and we should get 2 messages on the screen. Okay. So I don't like this right here. That's not right. Bottom is 1. And the reason why it's not right is because I did it wrong. I should have put it there. I put this reply is not bottom. It's the player ID. So that's my fault. There's nothing wrong with the code. I just put this echo in the wrong spot. It is right here is where I should put it. And then I would need to do a get on this as well. So I could do I could just do the ground. Well, I'll do both of them. So I go SG CMD, and I could say get sprite B, and then I'll just put the sprite in player. Okay, and so that's going to reply. And I can also put ground. Ground is, and I'll just use the ground variable because we already know that should be something. So that should be correct this time. So I've done everything correct. And so we have bottom is 535 and ground spelled wrong is 535 and top is 373. So I didn't know what top was off the top of my head. I was just like, let it calculate it for me. No big deal. Because wherever we put it and however the height, how tall the, come on, why did my laptop just rebooted? Cool. Interesting. Let's just make sure this live stream is still rocking. Hello. Yeah, I would have saw the hello, but my laptop just rebooted. And this is still working, yes. I don't know I never know what's going on with. Let me just log that. Just got my other laptop here trying to show YouTube, so if anybody's talking, lost quit. Oh, thank you. I was thinking about doing another NV one. I was kind of going down a rabbit hole where I was trying to build it from scratch without using NV Chat at all, you know? And basically, they've intertwined some of their stuff tightly in with the NeoVim. So, like, the way that they're theming things, they've kind of really twisted it in there. And I kind of gave up on it after a while. I was like, I'm going to have to redo all this from scratch. And so I'm going to revisit that. I kind of will do a whole bunch of work, spend a lot of time, get a little bit tired of it, and switch to something else. I'll show you what I did switching things in a minute. Correct. Okay. So yeah, just to show kind of like how I kind of do this thing. I was working on this. Sorry, I'm just going to take a tangent here. Let's see. So I was working on this, which is yellow snow. But with its own neural network that can train itself and can run itself and everything. And I went down this rabbit hole, and this was grand, and I was pretty much done. I did everything that I was going to do with it. So it's I don't know if you've seen this before, but so I don't know if you've seen this before, but like this is the game. Can we just do a run on this? I can't even remember. It's been a long time. It's been a couple months, but that's a long time because I switched to like 4 or 5 different projects. So this is the Yellow Snow game that you just saw, but it's written in C. Great. That's not interesting. But what this Yellow Snow game has is its own neural network, and so it can play itself. And now I have to remember all the incantations. So AI on. Sure. And let's say new 15. Let's see if it can run itself. Now, this time, I'm going to let the AI play itself. So it's got its own little neural network, and it's going to play itself. It may or may not be working. I can't remember what new 15 is. It's one of my networks. I don't know how well it's trained. And it's loading the networks, and it's going to use the best one. and it's playing itself right now. So it's kind of silly, but it's a little neural network I wrote in C using no libraries. There's no libraries at all happening here. This is some structs. This is just what's a neural network? It's a bunch of structs. So, and it does all right. And you can train it differently, and you can add different amounts of hidden layers and different sizes of hidden layers and things like that. And it gets up to like 20 or 40 before it does something silly. And I'm sure I'm not, this was just me learning about neural networks, And so I was going to make some videos on this. And I don't know if you've seen like the training, like it can train itself, which is wild because it, let's see here. Go to. Go. Train. So we can put like crazy number of stuff in here. So I have 24 threads. Let's say I want to train 144 games at one time. So it's not gonna do them at one time. It's gonna do 24 at a time, batches of 24, but it's gonna do this job to 144 games. I just chose that number because it's some kind of multiple, right? And I'm gonna take the top 720 or 72 of them, sorry. And I have this as an initial deviation. It's a Gaussian deviation. It's an initial one. I went down a rabbit hole with this. This is the kind of the random, how much it mutates each time, the chance of mutation, how many generations. So basically, how many trials. So if I ran this right now, it would try to run 144 games. When it got done running 144 games, it would run each of them 10 times. Okay. So that would be, like 1,440 games it's going to run. And then it's going to take the top 72 of those and going to copy those, keep that version and mutate those same ones. So it keeps the original ones and it mutates them. So it's keeping the top half of whatever the score was, of the average of those 10 games played. And it takes keeps those original and also mutates a version of those. And then it does that again, and it does it 1,000 times, right? And so this is saying I want I'm calling it new 1515, which means it's got 2 hidden layers of size 15s. And that's just the file name there. And this is actually saying I want a new one. It's going to generate a brand new one. And it does this really fast. Like so that would be 1,440 games times 1,000. It would be like 1,400,000 games being played. And it probably does it in like 10 minutes or something. And this is all on the CPU. This is not on the GPU at all. This is just straight up CPU, C code, and let's simplify this. Let's do, I'm gonna just do 5 here. I don't know why I'm crazy with this. And I'm gonna put a 5 here. And I'm gonna say 1 generation. Hopefully it lets me do that. I can't remember if it does or not. And 1 trial. And let's say this is a new 1515. I'm gonna call it that, hopefully. I just want it to run 1 time and have a totally garbage thing. So hopefully what I want to do is generate a really dumb random neural network right now. That's totally not trained. It's going to train 1 time it's not, that's the idea. It's still going to make 144 versions, but like they're all going to be untrained. They're all going to be random. Let's try that. I don't know if it works with 1. Okay. So there is a timeout. So that kind of lag you saw was just a timeout for me to read something, which is like a 3-second timeout that I put in there. Okay. So this new 1515, let's see what that does. Now, if I were to, it should be really dumb. It shouldn't do anything. It's doing something. I mean, it's just going one direction, but it's not intelligent. It's just dumb. Let's do it again. Yeah. Okay, so it's not doing anything, right? But let's give it like 100 generations. Let's give it like 10. So it's going to average its score of 10. It's been a long time since I've this is what I was this is what I was working on several months ago before I moved. Yeah. So I'm going to leave all this stuff here. Everything is here. So hopefully this thing will train itself. And we'll kind of see it getting smarter because it's going to spit out the top like 20 numbers and tell us the score of them. And so we'll see it kind of get smarter. So this is a pause time for us to read. And now we're doing something. It's training. So we're in generations and we're seeing the score. It's getting up almost to 20. Sorry. Yeah. So it's already done. So it's played 144 games, 10 times each, and done that 100 generations. It didn't look like it got very smart though, but let's run it and see real quick. Now it's doing something. It might not be too smart, but it's reacting now. I could have just pressed space, I think, and restarted. I can't. So it's doing something, right? So let's give it a little bit more, you know. And when I didn't need to press new on this because when I did that last time, now it's going to use the one that I've already done. So it's going to tell me that we've already done like so many generations. So we might see something that like there's 40 generations. That's because that one has not been cloned. It's even though 100 generations have gone by, I'm using one that's only been mutated like 40 times or something like that. So let's give it how many generations? Like I don't think we need that many, but I'm just going to say 500 trials. And I think the most important thing is the training style of it. I can't remember, but who cares? So that's just a timeout, and now we're rocking. So we can see this, we're almost at 20. Hopefully this will start bumping over 20. And this down here is the generation we're at, but this is how many of generations that this has made it. Did I lose my stream? Or is it just YouTube? I think it's just. Oh, we're up here at like 30 now. And it's at 400. Yeah, this is rocking around 30. You'll initially get very big improvements, but later on the improvements will be smaller and smaller, or maybe not at all. And it's really like you end up tinkering with this forever. But let's see how this guy runs now. And I can't remember if I can mute it or not. So it's kind of making better decisions. It still ran into something. Okay. So yeah, so I was working on this several months ago, and I was like, right, this is good enough now. I need some way. I want to show somebody else how to do this because I wanted to know, hey, how can you just build a neural network, just a simple one, and like without all the fluff. People say, oh, we're going to build a neural network in Python, and then they use a bunch of libraries that are not Python libraries at all. They're C libraries like PyTorch or something like that. It's not Python. The Python is not. You don't do AI in Python. There is no AI happening in Python. If somebody tells you that AI is happening in Python, those are script kiddies. They're not coding in Python. That Python is happening in Rust or in C or C++ or something else. They're scripting it in Python. And I just wanted to know how it physically works. And it's really not complicated. I mean, an LLM is probably very complicated and different, but this thing is just a, what do you call it? Forward feed. It's a evolutionary network, right? We're just throwing a bunch of random things out there, and whatever happens to be doing better because of the weights and the offsets then it's going to be better. So I wanted to show people how to build this, and I was going to say, you know what, I'm going to switch this over to SDL3, and I'm going to build this project, and then the Yellowstone project in SDL3, and then we're going to convert it to how to make it AI where it can train itself and all these crazy options I put in. But the problem is SDL3 is it's a dumpster fire. So SDL3, even though they've claimed that, let's see what version of SDL3 is out right now. Is there like an official page? Not too from. I just want to know what. Okay, so we have version 3.2.24 is the current stable version. Great. So is it ready? Is it stable? It's not, because you can't. I mean, you can technically. This is like what is a lie. Let's equate this to something. You go down to Ford or Tesla or somebody or GM or whoever, and or Volkswagen or somebody, and you're like, they tell you, we got the brand new car, it's done, it's ready to ship, here it is. Okay, so you go, okay, I'll take that car, and they give you the frame of the car. Okay, it's done, it's finished, it's completed, it's the 2026 model, here it is. There's no tires on it, there's no windshield in it, there's no engine, it has no engine. What's going on? Well, the frame is done, but the frame is not a car. You can't do anything with the frame. You can't drive the frame around. You need wheels on it. You need transmission, tires, or propulsion system if it's electric, whatever you need. You need the whole package, right? So SDL3 is not that. SDL3 is like the frame. But what about sound? Well, that's cool. The sound is not here. The sound only works with, let me compile the sound real quick. Let's see, it's called SDL3 mixer get. This is what it's called. I'm going to delete it real quick. Okay, so we can get clone, and let's go with SDL3 mixer get. This is the only version that I could find. Okay, so we're going to go into there, and we'll do a make package. Yeah, cool. So is this going to work? Is it going to work? And it's not going to work. Why? Because I need SDL 3.3.0. And correct me if I'm wrong, but that doesn't exist because the version is 3.2.24. So all I need to do is get a time machine, have, Doc and Marty take me to the future and get the version of SDL3 that is really the done version. Because this is not the done version. This is I'm going to tell you it's done, but it doesn't actually work because it's missing the sound. So it's like, yeah, this is absolutely insane. And you might be wondering, am I compiling the wrong thing against it? No, this is not done yet. This is the only, and what I could do is I could clone the unstable, right, SDL3 and compile it. But if I do all that work, who's going to be watching these videos and doing all that too? There is a stable package out there on Arch Linux and maybe other systems too. On Arch Linux, there is an SDL3 package, right? Go away. Don't know what this is. Okay, so for packages, SDL3, we have an SDL3 package, and you have to use this package if you're on Arch Linux. If you want to do SDL2, you have to use this package because SDL2 is not really SDL2 in Arch Linux. It is actually SDL3. They're using this SDL2 compact. This is a whole, and this SDL3 has been a bit trash since the beginning, although it does have new features and I want to use it. It has been incredibly buggy, something I would call an alpha build. Even though they're claiming it's version 3.2.24, no, it's not stable. It's an alpha build, but you can't just use SDL3. You need, the other SDL2, right? The SDL mixer, right? SDL2 mixer, SDL1 mixer. Where's the SDL3 mixer? You also need TTF if you want to do, if you want to do fonts, right? So, there's a Haskell. So there's the SDL2 TTF, the SDL1. Where's the 3, right? The image, if you want to load images, right? There's the 2. So if we go over to the AUR, somebody has been nice enough to set it up. Again, you could compile it yourself, but you don't know if it's going to compile against the package because none of this is stable. Let's say 3. Let's just put SDL3 here and see what we get. So here's our SDL3 TTF, and this version is for the 3.22, so that works. I can use that. The image, yes, I can use that. And there's a sound one. I'm not really sure what that is. Where's the mixer? Okay, so here's the mixer, the one and only package right here. And guess what? That doesn't work. And it has, I don't think it has anything to do with this package. It's all about this is not done. This requires a future version of SDL3. That means SDL3 is not done either. And they're telling you it's done. They're saying, please use it, but also it's not done. So back when I'm back here again, at this thing, I'm stuck now because I'm trying to show people how to build this in SDL3, but the sound system doesn't work. So now what do I do? Well, I got to back up to SDL2. So I kind of gave up on that project and I started writing my own programming language called Hue. And I was playing around with that for a while. I got to the Lexer and a little bit past there, I'm still working on that. It's just a toy project. Again, I'm not trying to reinvent the wheel. I just want to know how things work. So then we go to what I was working on after that is, I must have called this Yellow Snow OpenGL. Yeah. So start playing around with OpenGL, trying to understand OpenGL a little bit. So can we do this Yellow Snow game? I'm just going to clean it. And okay, so we have this Yellow Snow game. I don't want to make it full screen, but this is using my own render, that I wrote. So you'll see that I'm linking against SDL3, but I'm also using GL, a bunch of GL stuff. So what's happening here is I have my own 2D render, my own shader, texture, right? Can't remember what I'm doing with the shader. So I'm kind of re-implementing SDL's render, but doing my own version in OpenGL. And I was like, well, that's cool. It's 2D, but what if we, OpenGL, you can do some 3D stuff. So what you just saw there was me using an OpenGL render that I implemented right here myself. And I'm using that. It says my TTF. I'm really still using the SDL TTF, but to actually render it, to make the textures and stuff, I'm using my own version. So we're going to see in here that I am still using, for making glyphs to the surface, I'm using the SDL one. So we have the TTF blended, that's giving me the surface. But then when I want to switch the surface to a texture, I'm now using my create texture from surface version. So yeah, that's cool. That's 2D though. So like, what if we wanted to do 3D? So I was trying to figure out how could I do a little cube here. So I have this other source code up here, um, right here, and I have a 2D render and a 3D render, and this is some of the same old stuff. So let's see what that does. So I'm going to do a make clean on this because I'm going to switch into a different thing. Say source directory. Let's say cube. Is it called? I don't know. Make release run, maybe, hopefully. Let's see if this works. And so now I got a monkey. And so what you're seeing here, this is my 3D render, what I have of it. And also the loading of this mesh right here is I made that from scratch as well. So like I'm loading a mesh from scratch and rendering it. And what if we want a toon shader? So I can't remember. I think it's this guy. Yeah, there we go. Now we got a toon shader, right? Now we got some lines around it. I can make the lines bigger. Or I can do white lines or black lines, right? So yeah, so I kind of like went down this hole, started building this. And so now I have this 2D render and a 3D render. I kind of understand half or a quarter or 10% of what I was doing here, but I was just kind of chipping away at it, doing more and more stuff, playing around, changing stuff around. What if I do this, that? What if I want to implement this toon shader? How I would do that, and all this stuff. So, um, and that's going to be something evolving. It's going to take me a long time to figure this out. But this is how I'm loading the meshes, and I just got the meshes from Blender, and I have different versions of them. Let's see here. Where are the meshes? Did I just chuck them in the? Oh, I must have put them in here. I called it shaders, but no. That is my shaders. Okay, so where's the message? Oh, models. Okay, so I have a low, a medium, and a high, and I can't remember how I switched them out. So let's look. Don't think I have an option. No, I don't. Events. So where's my event? Update. Okay, so I got some stuff going on here. See, escape, up, down. 1, 2, 3, 4. Yeah. Okay, so I think I have to like if I want to show the simpler model, I have to do it manually. So where am I loading? Probably here, maybe. What's it called? Suzanne? Not here. Check it game. It's been like a month or two since I've been in this code as well. So I'm not loading it here. Main. Gotta be in game. What am I doing? Load media? Do I have a load media? I don't. 3D render. That's the cube. Cube new. It's in cube. This must be. There's Suzanne. Okay, so model Suzanne. So let's do the low version or the very low. Let's check out the very low version. I just hard coded it. I was just learning stuff. So I could have just done it as very low. And this is the simple object one, which is just a text file because I didn't use anything on this. So this is like, I'm using no libraries with this other than the SDL library for drawing the frame of the window. Everything else, it's my own code. Let's rebuild it. And so this is the low poly version or the very low. can do different versions of it, that's pretty cool. I like that too. It's like a different art style, kind of, you know. And if we just go with the low, whoops. That's looking like the nicer one. Yeah. But yeah, I was playing around with this, just learning about how to do that. And so then I thought, well, is there some binding in Bash, like to do this stuff? So I kind of switched contexts again and started playing around with Bash. And then this is so annoying right here. You have no idea how annoying this is, because I was making content for SDL3, and then they rug pulled me again, and they've done it several times, and they've had all kinds of stuff where it would give you false positives, and they weren't releasing memory properly, and then they would just say, yeah, but that's what they do. They don't write C code properly. That's just what they do. And it's been very annoying. This SDL3 has not been stable the entire time. But then they said, you know what, that way that you were doing sound before is not actually the SDL3 way. You need to do it this way, but it's not available yet. So you're going to have to go into the future and get that. So this, back to here again. So I kind of just wanted to show there's different backends. So let me just show you the fact that there's these different backends. I'm going to take this bit out. Actually, I'm just going to back up all this stuff that we added in. Okay. And actually back to this. Okay. And fix that one. So the reason why I have this code up here, because there's different backends, there's different ways to communicate through Bash and C. And so what I've done here is I've given myself this option, and then I went down a rabbit hole with each of these, trying to find out how you would talk between Bash and a C server. And if you ask the AI, you get some really terrible, terrible answers, which is you just need to use shared memory and you use a client program. So let's show that. Okay, this is the fastest way to do this according to the AI. So examples, and this is yellow snow. Okay, so instead of using the pipe backend, I'm going to use the client backend. What this is, and it's going to complain, actually, watch, because I didn't compile the client. Okay, so normally you wouldn't need to compile the client. The client is stupid, but it's this little tiny program that is just, all it's doing is spinning up and connecting shared memory. And sending the message, receiving the message, spitting it back out if you need it, and shutting down. So the whole program is like 300 lines. Yeah. So let's compile this using optimization. So make C, and we'll do the release version is optimized. We'll do it for client. Okay. So now I'm going to do this yellow snow with the client, and yay, it works, but it looks a little bit dodgy. And I'm going to hit the FPS on it, and we're getting 20 FPS. And this is as fast as it gets. So this is not good. And you can see I'm using delta time here on the flakes and the movement. So even though everything moves the correct speed still, but the frame rate is really low. Okay, so what is happening is there's the worst thing that you can do in a tight loop is try to spin up a little client, have it send a message and shut down. That's a terrible idea, because my code here may be communicating back and forth from C. Make sure it's still running. It's communicating over and over again. So like, let's look at here, this SG CMD. Why am I not? Why can't I search? Oh, I'm looking at the wrong code. Okay. So each one of these, this is no problem, because it happens before the loop, right? But when we get to the game loop right here, we get to the game loop. This is being called every frame. This is being called every frame. These are being called. This is in an if statement, so maybe it is, maybe it's not. And now if we are in the playing mode, this is being called every frame. This may or may not be. But we're going to go through all the flakes, and then we're going to do this. So now we're doing this 15 times at least to get the rect. Okay. And then we are going to, that's if it's playing, we're going to do this every frame, do these every frame. And then we're going to go through all the flakes and do this, which this is not optimal. We could probably do this a better way. But there's a whole bunch of communication happening. It could be several hundred times a frame. And the client is incredibly slow because you have to spin that up. And then using shared memory, you're talking to the server with shared memory, which I have basically a communication one and a lock one. So I have to lock or unlock a state, and it's got to spin and wait if it's its turn to communicate, so it's synchronized. But that's not the slow part. The slow part is the spinning up. And I can show you this because we can actually talk to shared memory directly from bash. So the server has a bit of memory that it's looking at, that is mapped, and this client maps that same piece of memory and then sends and receives information on it, right? But it just does it once. So we can actually do this straight from bash. And that is what is the other backend. So this was the client backend. And basically, it sets up the server and it sets it up so the client can communicate the server. And we've already seen a pipe backend. I'll just show you what the client backend looks like. This is just seeing what environment, if it's bash or ZSH. I'm setting up some variables right here. I am making sure that the server has been compiled, or I'm going to tell you to compile it. And I probably should change this message. This one needs a client, so I'm making sure the client is also compiled. I need to create these two shared memory files. Now, this does not work in Mac if you're a Mac person, but don't worry about it because you're not losing anything. This is a terrible idea. So we're using these dev shim, like shared memory things, and I'm creating two files here. So yeah, so I'm touching them here, so they exist. And now, before I get the client going and the server going, I want to make sure no communication is happening yet. So I'm setting the kind of the lock to 1. That means, hey, your bash client app cannot communicate yet. The server's not ready. And the server will zero this out when it's ready, and then communication can start. So that's just a way for me to synchronize or to make sure everything's up and running. This is making sure the server isn't running yet. If there was an old version of it, now I'm starting up the server and I'm sending in the PID of this script to the server. So if the server dies, it can kill the script. But I'm also grabbing the PID of the server. So each of them, the server knows the process ID of the script, and the script knows the process ID of the server, so that each one can shut the other one down. And I'm making sure the server has started now. And now I'm defining the two functions that I need, which is the sgquit and the sg command, right? So this is the one that you use all the time. Basically, if I'm just sending a message with anything that's not get, new, array, or free, I don't want anything back. So I'm just sending the message directly to the client and whatever the message was. But if it's a get new, I need something back. So I'm going to read a reply back from this little app before it closes. And if it's an array or free, I need to get back an array. Now, I used to have this written differently, but because I wanted to work in ZSH, I had to write it differently so it works in both bash and ZSH. But basically, this is an array coming back. So that's the client one. And basically, the client is connecting. I'm talking through the client. I'm spinning up a client and passing something into the client. The client is connecting through shared memory to the server, it's giving that information, waiting if it needs to come back, and then sending it back. It's very slow. So the way to bypass this is just to not have a client at all. So we can do shared memory directly from Bash. So a lot of this is the same kind of stuff. Setting up the shared memory the same, setting up the lock the exact same. So the lock is waiting for the server to be ready. Okay. No client is involved here though. So the server's up and running, or making sure it's not running. Now we're starting it. We're making sure it is running. And now we're defining our quit, which is going to look similar. I'm not really going to talk about that. It's not interesting. Here's some traps so that the server can tell the client to shut down or vice versa. And right here, this is where we're doing the shared memory. So I'm using file descriptor 3 and 4, which is up here. Yeah. So I have data and lock. So data is going to be my file descriptor 3, and lock I'm going to be using 4. So lock, here's 4. I'm setting it up, and I have to set up for read-write, because if I set it up for write only, it's going to change the size of it, and then my C server will crash because it's looking at the same piece of memory, and suddenly the size of it changed. So the size cannot change. So you have to connect with read-write, even though I just want to write to it. Or I'm reading from it. Yeah, I'm reading from it. Sorry. I'm reading from it, but it needs to be read-write. It can never be just write. So this is me using file descriptor 4 on my lock. So my lock is literally just 1 byte. That is either going to be a hexadecimal 0, 1, 2, or 3. So if it is a 0, that means my client, the bash script, is allowed to talk. Yeah. So I'm checking to see if it's 0. So I need to connect. I'm going to read one character or 1 byte or whatever from it. And then I got to close it. I can't leave it open. I got to close it right away. And we'll see why in a second. But I'm storing this as status. So I'm going to check, is this status hexadecimal 0? If it's anything other than 0, I'm spinning. I'm going to continue and I'm spinning. If it is 0, that means it's my turn to talk. And so right away, I'm going to connect the data to file descriptor 3 using read-write. Again, we can't use write. I'm going to print what I want to print to it. So am I sending 0? Oh, sorry. I'm looking at this. I want to send in my string, but the printf doesn't add a null character at the end of it. So I'm adding a hexadecimal 0, which is also a null character. Now this is to the data, not to that lock one. So this is the actual string that was sent into this function. So when I call this function, $1 is the first parameter, which is the string I sent in. So this string is being sent to file descriptor 3 with a null terminator after it. And then I need to close it. And you're kind of like, why do you need to close it all the time? It's because Bash cannot rewind. So I'm looking at a piece of memory, and if I keep writing to it, it keeps moving along the memory. It can't go back to the beginning. So I keep having to close it. I have to open and close it every single time. So I'm opening the data, I'm writing whatever string to the data with a null terminator, closing it. Now I'm opening the lock, and I'm setting the lock to 1 and closing it. Now the server has been spinning the whole time too, and the server is saying, the second I see that thing 1, I'm reading data. So the server is going to see this 1, and it's going to read the data and do whatever it needs to do. But it only does that when it sees 1. So when I have 0 on the lock, I'm writing, and then I'm setting it to 1. Now, if it's a get or a new, I need something back. If it's not a get or new, I don't need anything back. But if it is a get or new, I need something back. So now I'm looking at the lock again. So now I'm spinning again. I'm connecting to the lock, getting one thing, closing it, seeing if this is a 2. So basically the server, when it reads 1, it can read data. When it's done reading the data, it'll write its answer back to the same data, and then sets the lock from 1 to 2. So when my bash script sees 2, it says, now it's my turn to get an answer back. So when I see 2, now I'm going to connect to data, I'm going to read the data and close it. And then I'm going to set the lock back to 0. So now I got the data, I can set it back to 0. I know that I can send data again, basically. Now, if it's an array, which could be array or free, could be arrays coming back, it's very similar, except the data that I read, I put it into an array. It was different before. I used A before, but that doesn't work in ZSH. And the same thing. So this looks incredibly complicated, right? But this is way faster. Okay, this is like 10 or 15 times faster. Okay, so let's see this. Now, internally on the server side, this is the exact same. So I'm starting up the server in shared mode, whether it's the client or the shared version, because the server doesn't care. The server is just looking at shared memory. The server is doing the exact same thing. The client app and the bash shared one are implementing the bash side differently. So client, we got 20 frames a second. Here's shared. Okay, press F here, and now we're at 160, 150, it looks like. And remember, I am streaming. But, you know, this is, sorry, not 10 times faster. What is that, like 7 times faster? Let's do the other one real quick. Okay, so it went from, looks like 19, 18, 19 to like 160. Yeah, so almost 10 times faster. There is other stuff happening here too. There is, I'm streaming for one, but another thing is this is just, I'm just talking about communication. There's actually other stuff happening in Bash in this yellow snow. You know, there's not just communication happening here. There is logic that's happening here in Bash. So what if we didn't do this whole shared memory thing? What if we used a Unix socket instead? Okay, so we have a Unix socket backend. Where is it? Socket here. So on this one, same kind of deal up here. I'm just checking to see if you're in Bash or ZSH, setting some stuff so you know it plays nicely. The name of the server, the path to the socket, making sure server is compiled. Now I'm starting up the server in the socket mode. Again, it's getting the PID of the script, and also I'm getting the PID of the server, making sure that it is running. And now I'm open. Now this is so goofy because Bash and ZSH implement this coprocess thing, and I'm not an expert at this at all, but they implement it differently. This is the way I got it working. So this works in Mac with Bash or ZSH, and it works in Linux with Bash. So if you're using something else, I don't know, and it's not POSIX compliant because I'm using arrays and stuff, but it is Bash. So if you're in ZSH, this is the way you're doing the coprocess with the Unix socket, and you have to use P for the file descriptors. If you are in Bash land, I had to put this in an eval because if I just have this as the else, ZSH will read this else anyway, even though it doesn't go down this branch, and it'll fail. So it's in an evaluation to get ZSH to be happy with this, but this sets up the socket in ZSH. So now I have my quit function, not very interesting. It's just kind of cleaning up, and the traps again. And now this is my implementation. So now we're talking on a socket. We can just echo the thing to file descriptor 3, which is this socket that's writing to the server. And when we want something back, if it's get or new, we are reading from file descriptor 3. And again, before I used an A here for the array, but because of ZSH, I'm using a version that works in both. So that backend is implemented. So let's try it. So we had about 160, I believe, with the shared memory. So here, 600. So when it's idle, it, you know, so it looks like 600, 615, 620, yeah, somewhere around 600 to 620. Okay. So can we go faster? Well, the socket has a little bit of overhead going on. We can use a named pipe, and this works as well in both versions, both ZSH and Bash. The thing that does not work in Unix land is the shared memory. So the client and the shared memory does not work in OS X. Bash or ZSH. It just doesn't work in OS X because the shared memory is like a Linux thing specifically. And I tried to ask the AI, like how I could do that, and they suggested that I write to a temp file instead. And that temp file would be your SSD, and I would be like destroying your SSD. I'd be constantly writing and reading for it, and that just sounds like a terrible idea. Whereas the shared memory is in RAM. So yeah, not doing that. So the Unix named pipe version, all this stuff up here is the same. This is the same. Making sure the server is compiled. I'm making these first in, first out pipes right here if they don't exist. I'm starting up the server in pipe mode, grabbing the PIDs both ways, making sure the server is running. Okay, so this time what I'm doing is I have the pipe to server or the pipe to server and pipes from server. So I'm setting to file descriptor 3 and 4. And I did have variable names for these before in Bash, it looked really slick. And then when I try to switch over to ZSH, that was out the window. So I just went back to using 3 and 4. We have this shutdown function. It's not that important. It's just cleaning up. And here's our implementation, and it looks just like the other implementation because basically it's talking to file descriptor 3 and reading from 4 the same way that the socket one would have done. So let's see the speed of this one. The other one was about 600, 610, something like that, 615. So this is pipe. And this is fast, right? So it looks like 800 is fair. 830, it's bouncing around. Say 800, 830, somewhere around there. So yeah, this is as good as I could get it. Okay. So that's the speed, and you're wondering why I care if it's 800 frames a second. It's because that's a very simple game. You might want something more complicated. Let me just show you. Let me show you what if I wanted to make like text? I want lots of text and I want to do lots of collision detection. How could I do that? So I made this very overcomplicated script that I implement collision detection different ways. Let me just show you one more while I'm here talking about this. I ended up with one more version called standard in out, and I don't recommend you use this. Although it works, it seems like it would be very easy to be broken. So again, this is doing the same thing. Everything is the same here, all the same. Here, what I'm doing this time is I'm using a coprocess, but I'm chucking the actual server in a coprocess, and I'm reading and writing through to the server through standard in and standard out. Okay, so this works, but the problem with this is if my server was to send any message, like the SDL part of the code or something just echoed or printf, anything that is not me sending information back, it's all going to fall apart. So I don't recommend you using this, but this was another option that I came across. So basically, I'm communicating to the server through its standard in and standard out, the 0 and 1 file descriptor of the server, not of the shell. We're going to map it to 3 and 4. But yeah, and because we're using this coprocess, we have the two versions. We have the ZSH version here with no name in front and using the P, and then we have the bash version here where we have this in front, and we can now use that. But we're mapping them to 3 and 4, to the file descriptors 3 and 4. So the cleanup is very simple. We didn't really make any files, so we don't really have to clean anything up, but the file descriptors. And this is all the same again. I left the old versions in. This is not right. This used to be an array version. Sorry. No. I didn't need it this way. Why did I do that? I was probably trying different ways to see if there's any. I don't believe these are any different. I believe this works, right? Maybe it doesn't. We'll find out. Oops. So this is the S standard in and out, and I don't know if I just broke it. And I don't recommend that you use this. And it's fast. It's basically the same as the pipe. But again, the pipe, we know we're talking on a pipe on both ends. This one, the server, anything that the server spits out gets gobbled up by the, and it's going to totally mess you up. So don't recommend you using this, but this is just another way to talk to the server. And this works in both. So you can use both of these well. Like basically I'm reading from file descriptor 4, or I'm using the read with the U file descriptor 4, same thing. Yeah. So all that's cool. I recommend using the pipe one. But again, I was trying to say why do I care if it's so fast? Because your game's not going to be as simple as what I just made, right? So I made this very overly complicated. Let's just show sprites real quick. No, text. So I have this text one. This is the same boilerplate right here, different backends. And what I wanted to do was see how many text I could draw on the screen at once. But I started thinking I can check the collision by getting the right, getting the top, getting the left, getting the bottom, one at a time, and then checking that. I could do it that way. Are we still live? Moves. Yes. Okay. YouTube is so weird. I think it's still live on YouTube. It's not showing me correctly. I don't know. So basically, this is a test program. So I implemented a whole bunch of things in here just to see, like what works. So imagine you want to do collision detection, and I make 200 text objects. I want to check the collision on all of them. Well, the dumb version would be just to get each one into, like, put it in a loop of 200 and get the top, the bottom, the right. And that's not very smart. So then you could do it even better. You could say, you know what, I'm going to just ask one time instead of 4 times and get all 4 directions at once. Or you can be even smarter and you can say, you know what, I just give me 200 lefts in an array. Give me 200 rights in an array. Give me 200 tops and 200 bottoms. So just 4 times. And the same thing for the drawing of these. I can say, hey, draw all 200 in one go, or I can say draw the 200 in a loop separately, each one, right? And that's some information you're sending and receiving separately each time. So this implementation has a whole bunch of versions in it, basically just checking my code, how fast it could be. So let's look at this. So this is examples, and we're going to use pipe. And this will be called text test. Okay. So what I got here is a bunch of text moving around the screen. Now, this is an array of text objects. They're all different text objects. And there is an array of x velocities and an array of y velocities. So they're all different velocities, and they're all being applied. Like you can see this one's moving very slowly this direction. They're all unique. So basically I have an array of text, I have an array of x velocities, an array of y velocities, and I'm applying it to them. And I'm using delta time on all of them. So I'm going to put it on the dumb version where I'm doing everything the worst way possible. Okay. So you can kind of see it's a little bit slower. I'm getting 40 frames a second, right? So this is 200 text objects jumping around the screen, and I'm doing everything in the worst possible loop. I'm not using arrays for anything. I'm doing everything as a separate thing. So what if I just draw these text objects, instead of drawing each one of them singly 200 times, if I just tell them all to draw once? So I send one with 200 IDs and say, hey, draw those 200 IDs one time. So I'm not sending 200 bits of information. And we're at 42 roughly now, and I'm pressing the 2, and now we've gone up to 49, 46, 47. We've gotten faster because I'm communicating less, but I'm still doing the same thing. Now, if I press 3 and 4, it's going to go even faster. I can't remember exactly what I'm doing. I think 3, I'm getting the top right, the the X and the Y and the bottom and the right to do collision detection all at once. So right now I'm doing each one of those separately for all 200 things. So that's like 800 just on receiving the information, each frame. But now I'm going to switch it down where I do one check for each. I ask the server for each object, and I'm going to get all four together. So that drops it down to 200. So I'm going to hit 3 now. Oops, that's the wrong button. And I'm hitting 3 now, and we can see we're up into the 50s now. Okay. But what would be even better is if I just got all the lefts, 200 lefts in one shot, 200 rights in one shot, and I can do that. So we're in the mid 50s now. So now I'm going to hit 4. And we can see now we're up into the 70s, 80s. Okay. So this is 200 text objects moving around with their own velocities. There are different sizes. They're all bouncing off. This is really cool. So what if we didn't just have static text objects? What if I wanted to make these say, instead of saying hello, what if every single frame I actually put in like where their X was? I think it's the X. Like I used X or Y. I forget which one. But and so instead of saying hello, it's going to say it's where it's at, right? And I'm going to use the other ones, the Y, the top and the bottom, to set the color. So every single frame, I'm going to change the text that's in the text object, and I'm going to change the color too, based on where it is on the screen. Okay. Now here's the worst version, back to the dumb version again. So it's going to be slow. But let me show it to you. This is 5 here on my screen. This is because I'm using the dumb version where it's doing everything slowly. So I'm getting 27. And the colors are changing each frame for these texts. If you kind of watch one of them moving around, but it's too slow. So 6 is more a little bit better. 7 is even better. We're at 33 now, and 8 is our optimal one. And now we're back at 53. Now let me say again, every single frame, I am changing every single one of these text objects. I'm changing the text, which has got to re-render what it is, and I'm changing the color, which it's going to re-render what it is. And I'm sending that information every single time. I'm also doing bounds checking. And what if we wanted them to spin? And they're all using delta time. So what if we wanted them to spin? Let me press 9. And now all these objects are spinning with their own rotation. Some are spinning forward, some are spinning backward, some are spinning faster than the other. And they're all using delta time. So that's why I was worried about speed. Because if you have a game, you're probably going to have lots of objects or lots of things being checked, or, things that you need to do. So I'm sending and receiving like 1,000 times a frame here, but I'm still getting 40 sub high 40s, right? So that's why I was worried about speed. Now, if I were to show you the same thing with client, it would just crash. It would be crazy. But let me show you. So I'm getting 46 now with the spinning ones. Let's do the socket or the STD. I think no, it would probably be about the same. I'll just go right to 9 and hit there, and we're getting 45. Usually it's and the same as the pipe one. Maybe it's not. I don't know. Let's do the socket. And there are 200 of them. And this the 9 with the socket's doing pretty good. Okay. When we get to shared, we're going to drop down quite a bit. And 9 with that. So now we are just struggling here. 10 frames a second, right? So what if we try to do client? I'm pretty sure client will just crash. Maybe it won't. And put it on 9 and put it on F. And it actually did crash, because what happened is something, because of the delta time, an object moves so far off the screen. The way I was doing the color, it actually gave me an invalid color number, which is right here, a -4, invalid, because the frame rate was so low. So that's why speed mattered. Here's another example of sprites. Sure. I don't know if I'm still streaming. This one. Maybe I've lost it. Always problems with the internet. Let's see, am I connected? Okay. It says it's still going, so maybe it is. I don't know. Okay, so I have another test one, which is say sprites. And we're going to skip the whole client thing. We're just going to go right to the pipe. Okay, so this one is not 200 this time. We're at 400. And I've set the render to the pixelated version. You can use the smooth version too. That's an option. You can switch back and forth. But you do need to do it before you load it, because texture, it has to be set before the texture is loaded. So I can spin them using delta time with my right and left. I can shrink them down. I could spin them and we're getting around 50. And again, this is 400 objects. So that's pretty cool. I can also change, and I'm going to load every single one of these as a sprite. So they're all referencing a different image. You can do it differently. I could use Rex and used one reference image instead because you have options. But this one, every single sprite has its own image. So I'm going to hit W and it's going to change all of these sprites to the white version. And it should change the one up here. There we go. So it actually just loaded 400 images really quick, right? And let's try snowman. I'll probably stutter on that one. Yes, because the snowman's a bigger thing, but we have the snowman. And yeah, so not too bad, not too bad. So basically, you can kind of do a lot of things here. What about the mouse? Does the mouse work? Surely the mouse, bash mouse. Looking at this YouTube, it's pretty rough. So mouse test. YouTube is not receiving enough video. This one not, am I not streaming right now? Must be something. I don't know. Is it playing? Maybe this. Do I need? Okay, so if I move the mouse around the screen, very simple. And you can see I've anchored the center of these texts to the middle, so they actually do what they need to do. If I press the button, the left of the mouse pad, the center of the mouse pad, the right of the mouse pad, no problems here. I can do held down or tap, basically just a little test thing to make sure my mouse code was working. We also have, you can also free objects if you for some reason, all my image and sprite and text, the text regenerates the text for you, so it's very simple. The image, you can just tell it to be a new image if you want, and it'll just put the new image in there. But if for some reason you wanted to remove an image, if you wanted to delete it or something, you can do that as well, and it will free it. You don't need to, but it'll free it, and you'll set that. You'll need to capture the new ID, and it'll be like a -1 ID, which is an invalid ID. So if you try to use it again, it'll crash on you, and well, it won't crash. It'll shut down nicely, and it'll tell you politely that you're using an invalid ID. But you don't need to do that. It does it for you anyway. So I don't know if anybody had any questions. I don't think anybody's watching this. I'm not sure if anybody's watching this. I don't even know the state of the stream. Let me turn on the light. But basically, I kind of explain all this over here in the documentation. So what do we have here? We can set some basic stuff. We can set title, icon, the size of the window. We can set things to full screen or toggle full screen on and off. I can't show that. We can get the width and the height of the window if we want, or we can get it as an array that has the width and height together as a returned array. We can do, if we want the scaling to be smooth or pixelated, we can set it. By default, I think it's the pixelated version, which I prefer, but I think that's just the default anyway. But you can set it to linear and it'll have the smooth version. That's when you're increasing the size of textures, how they scale, basically. We can set the FPS. By default, the FPS is set at 60. If you don't put any command in at all, it'll just automatically be 60. But I was overriding it and telling it to be like 10,000 so I can just see whatever it is. And you can get the FPS and it'll return to you whatever the FPS was over the last second. Every second it's updated and it returns to you an integer that's the FPS number. We have the render clear, render present. I haven't set like render colors or anything yet. Yeah, that's not there yet. Keys. We can give it a single key, and it'll tell you if it's being held or pressed or released. It's going to send you back a 0 or 1 that you can use in your logic. So that is a get key H or held, and a single key, like you can put space there or H or 1 or something like that, and it's going to return you back a 0 or 1 if it's held down, or here's if it's pressed, here's if it's released. But that's not very interesting to ask it about one key. So what you can do is if you have you need to know if a whole bunch of different keys are pressed, you can just add in all those keys and you can get the answer all back at once. So that is the arrays here. So this one is ARR, means that you're getting back an array. And it's an array of bools. I put bools here. They're really just 0 or 1s. And this for if you want their state, if they're in the down state, like being held down, or if they just went from up to down, as in a key was pressed, or if it was released from down to up. So all three of those. Mouse commands, the same thing. You can get like a single, you can ask it either the X or the Y, get mouse X or get mouse Y, and you'll get an integer back. You can do the same thing with if the button is held down, and you can choose what button, like 0, 1, 2, 3, 4, 5, whatever. On the press, those are for single things, or you can just get an array of however many buttons you decide. You could say 0, 1, 2, 3, 4, 5, and you're going to get back an array of the state of all of those buttons. And you can also say the mouse position, which will give you the array back of the X and the Y position. So if we look at that little mouse test program, it's super simple. This is boilerplate nonsense up here. I have two modes just because I was testing the array versus the singleton version. So these are just declared associated arrays, right? But right here, I am starting ShellGame up. I am setting the title. And now I'm creating these text objects. So it's very simple to create a text object. I say new text, and then I need to give it a font. I need to give it a font size. And then everything after that now is going to be the string. So this is the string that is in that text initially. Now, once I create that text, I can change the font and size, and it'll regenerate that text object for me. I can change the color, and it'll regenerate the text object of that with that new color. Or I can move it around. I can spin it or whatever I want to do with it. Or I can change the string that's in the text object. So we already have the ID of the text object. You can just do whatever you want now with it. So we'll see that. So right here, I am creating a text object. I'm using the reply global to set this now to text mouse 1. That's the ID of that object. And I'm also setting this I want the center Y of this. So whenever this text gets regenerated, it's always going to remember where the center of it should be, the center Y. So I'm setting the center Y to 100. And each one of these, the mouse 2, mouse 3, mouse X, mouse Y, I'm doing the CY 200, 300, and 400. But I didn't do the X. I can do all the X's at once. Since I want the X to be in the center of the screen, I can say set text CX 400, and then I can just put in all of them. If this was an array, I could just plop in the array as well. But this is just, I could just say, hey, set them all at once now. So those are all set now. This is an FPS 1.2 for displaying the FPS. That is, I can toggle it on or off, and I put it in the top left-hand corner. I set the FPS to 10,000. Again, if you don't do this, I'll show you. So this is the mouse test, and if I press F, say I'm getting like 2,000 FPS right here. If I were to comment this out, because we don't need it at all, now if I run it, it's 60. It's going to be 60, unless you're in a really slow machine somehow and it goes below that, but yeah. So in the loop, you always need to run this SG update, and what this SG update does is it gets the keys. It gets all the keys, so if pressed, held, whatever, internally, it gets that. And it also gets the mouse state. So whenever you query, it already knows that. It also times the game. So whatever you set your FPS, it's going to try to do that. And it also calculates what the delta time was. So anytime you're using a move or an update, anytime you call the update command, it's using delta time. And we'll see that in a second here. Let's see, array key pressed. So here is our command. I want an array back, and I'm saying key pressed. I want to know if the X, the F, the 1, or the 2 was pressed. I think F is showing the FPS. 1 and 2, I think, are the different modes of me using an array or a singleton. And I'm capturing them here. So I got an array back, and it's called a global array, but I know the first thing in here was escape. So I'm assigning my associated array to whatever the value was. So I'm just assigning. To make it simple, F is the next one down. So there's the F, there's the 1, there's the 2. So now I can check these. So right here is a simple if statement in shell. I'm putting this right here. If this is either a 0 or 1. If it's a 1, this is going to be run because I'm using a logical AND. So if this is true, this is run. If not, it's skipped. Same with this one. For this, I'm just toggling FPS on and off. So this is kind of a way to toggle on and off, saying 1 minus whatever the thing was. If it's a 0, it becomes 1. If it's a 1, it becomes 0. Very simple. That's just toggling. That's just for me to down here, if I want to show FPS or not. If this FPS is a 0, 1, if it's a 1, this is going to happen. If it's a 0, it's not. Very simple. These two modes, if it's mode 1 or 0. If it's mode 1, I'm grabbing all these singly. If it's mode 2, I'm using the array version. I was just making sure my code worked either way. And so what I'm doing here is I'm saying get mouse held 1. So I want to know if the 1 mouse button was being held down. So if the 1 mouse button is being held down, I'm setting the string that already exists. So here's the ID of the string that already exists, text mouse 1. So I'm saying set text string. Here's the ID of the string I want to set. And this is what the string is going to be set to, which is going to be button 1 and whatever reply was. And reply was the answer to this. It's going to be a 0, 1. I didn't hold it in a variable. I just used it directly. And I'm doing the same thing for mouse 2, mouse 3, mouse 4. And the same for the position, get mouse X. It's going to return a position number. So that's going to be in the reply. Get mouse Y, the Y position. Here is the array version where I just say, hey, get 1, 2, and 3. Give me the array back. And now I'm just using them directly. And the same thing for the position. I'm just using them directly. So I clear the render. I tell it to draw all the text at once, right? So I'm saying draw text, and I'm putting in the ID of all the ones I want. They're just going to draw all at once. And if FPS was turned on, I'm get the FPS. So whatever the numbers return from that, and I'm setting the FPS string to that. And then I'm also drawing the FPS. Right? I could have drawn it up here too, but I only want it drawn if FPS toggle is turned on. And then I'm presenting the render. So it's a very simple thing. This is very simple, but you can see how you can just once you've created the texture, you can now change it. And I could have changed the color, the size, the font, whatever I want. It's the text object is already there in the C server, and you can now just change it and it'll regenerate itself as needed. Okay, so that is dealing with the mouse. So these are the objects that you can kind of create that are shared memory managed for you. There's image, there's Rex, there is sprite, there is text, and there is music and sound. So in SDL, normally you would have an image, and then you need a source rectangle and a destination rectangle. And you need the source rectangle can be null if you want to use the whole image, but the destination rectangle, generally you do want that. So you can do that here. You can load an image up and you can use a rectangle, and you can use a source and a destination rectangle, or you can put null in for the destination rectangle. So let me go down to images, text, images here. So new image, an image file, and you get back an ID. If we want to draw it, we go draw image, and we need a source rectangle ID. We need a destination rectangle ID, and then an array of IDs of images that we want to do, and I'll just draw them all on top of each other because they'll be at the same rectangle spot. If you don't have a source, you can use null for the source, but you do have to have a destination rectangle. Okay, so that's kind of like the old school way. And this is also good if you're using a sprite sheet. You can do this too. But if you just literally want a rectangle for one image, you can just use a sprite, which just wraps the two together for you, and you don't have to worry about this nonsense. But if you're doing like a sprite sheet or other things, you may want this. So I left this in too. And you can set the image if you want. If you don't like the image that you loaded, you want to change it to a different image, you can do that here. It uses the same image ID. It just loads a different image into it. You can get the attribute like the width or the height, or you can write width or write height, and you can get that attribute back. Or as an array, you can get the width and the height back together. You can also ask for the widths of like 10 or 100 different images, and you'll get an array back of all those widths or of the heights. Not both width and height, just one or the other, because the array is going to be whatever the images are. And you can free a whole bunch of images, and you'll get the arrays of their reset IDs, which will tell you that they're invalid IDs afterwards, but it's good to do that. So the texts were here too. Where was it? Objects. So we have this image, we have this Rex. We kind of understand about the Rex. I'll come back to Rex in a bit. Sprites are wrapped together. So let's look at the text object. Here they are, text objects. So we've already seen new text, and we put a font, a size, and then a string, and we get back a text ID. Now we can draw. We could draw a whole bunch of them. Just give an array of text IDs, and they'll all know to draw each other. They'll just loop through all of them and draw. And they're drawing based on their own recs. Each text has its own rect. Okay? It also has its own rotation. So when you tell it to draw, it uses its own rect to draw itself. So if you tell 500 to draw, they don't draw on top of each other. They draw based on their whatever their own rect tells them to be. You can set the string. So you can change it basically, whatever the string was initially, you can change it to a new string, and it'll, based on its anchor point, be correctly, the rect will be repopulated, everything will be set back up for you again. It'll use the color that you set previously and the font that you set previously. You can also change the font and the size. You can change the color, and you can use the RGBA if you want as well, and then you can free them. So sprites are very simple. They're just image with the rect together. And these texts also have a rect in them as well. So there's stuff that you can do on everything that has a rect. So anything that's like a rect object, this is just, you can get back a rect from an image if you want. You can get back a rect of your determined X, Y, width, and height, or you can get back an empty rect that's all zeros. But anything that has a rect, you can move it around. And so delta time is important. If you want to move things, but you don't know what your frame rate's going to be, or you don't want to lock it to a frame rate, you can say update. And I put type here. Type can be either text, rect, or sprite. So any one of those three can be right here. So update, sprite, position. and then you can put an X velocity and a Y velocity. And then you can, after that, you put your list of sprite IDs. Okay. So that's going to update all of them with the same velocity, but they could all be starting at different positions. So they'll be moved by a velocity. And that, so say if I put 300 in, that's going to be 300 times delta time. So if my velocity is 300 and I'm running at 60 frames a second, I'm going to move 1/300th of of that 1/60th of that 300, because after 1 second I'm going to move 300 basically. So if my frame rate speeds up to 120, I'm going to move 120th of that 300. So the velocity is always the same. So you can choose a velocity and you can move it over a whole bunch of things. You can also choose a specific attribute, the X or the Y separately, and do the same thing. So if you want everything, if you had stuff raining down and you want everything to move down the screen the same velocity, but they all can be in different positions, you can just say, I'm going to set all the Y to 300 and apply this velocity to every rect or every sprite that I have, and that'll work. And you can also rotate things. And this rotation is also velocity. It's using delta time. So you tell it, I want to rotate by 360 after 1 second, after 60 frames. If it's 60 FPS, it's going to rotate 1 time, right? So, and if your FPS is faster, it's still going to rotate 1 time after 1 second. That's the way delta time. So these are all updating. You can also set things. If you just want it set to something, set to a rotation, set to a position, set an anchor point on anything that has a rect in it. Here's the set sprite position, and you can put an X and Y, and it'll set the position. Set sprite angle, set it to a specific angle. You can flip it. So you can flip it. I think I have this. Hold on. Let me check. Be in the image test. Okay, I'm really afraid to hit this full screen button. So I have a horizontal flip, a vertical flip, and a none flip, and an FPS. So let's run this real quick. So image test. So we have the image here, and if I want to flip it horizontally, so that flipped it, none, horizontal or none. If I want to flip it vertically, horizontally, vertically, or none. If I want to rotate it, or rotate it the other way. If I want to move it around the screen, right? Yeah. And that's none flipped again. So yeah, sometimes you like my snowman is flipping back and forth, so that's what you would do there. And then you can do that on any of them. You can do that on the text, on the sprite, on the recs. So images don't get flipped, but the rect, I put it on the destination rectangle. So whatever, if you flipped a rectangle, if you use that rectangle as the destination for an image to be drawn, it's going to use that flip or that rotation as well. So I put the rotation and the flipped property on the rect. So it's not actually on the rect, but it's packaged up with it. But it's for images. I put it on I use whatever is packaged up with the rect that is used for the destination, not the source. So that was updating things, and this is setting. So setting the attribute. So we can set X, L, left, Y, T, top, width, W, width, H, height, R, right, B, bottom, CX, CY. We can set all those for anything that has a rect. We can get that information back. We can get it back as an array if we want. So yeah, you're going to see this a lot here. I kind of implemented all of this. Get position, same thing. We see this holding again. We can get, one of them, or we could get it back as an array, I believe. Do I not? This is arrays, yeah. Okay, so this is getting single ones. I even have floats here. You can't really use floats in shell though. So like, I don't, internally it's using a float for movement and stuff for delta time. But like when you get back the position of something, you don't really want it to be a float because you're in shell and you want everything to be an int. So, but sometimes I do have some floats hanging around here. I wasn't sure what to do with them. So we can get back the array, like the x and y position of a single ID, or we can get the rotation of a whole array, and we'll get back of IDs, and we'll get back the array of all of their rotations. We can also get the size, and it's just like the above. Instead of x and y, it's width and height. Now, if we want the entire rect, basically, it's not just the rect; it's the x, the y, the width, and the height, the bottom and the right, and the cx and the cy. If you want all those back at once, you can just say, hey, array sprite rect, an ID of sprite, just one of them, and you're going to get this whole answer back to everything. So if you're doing like collision detection, you want to know everything about it. You don't want to ask a whole bunch of times. You just get it all back at once. But if you just want one of these, you can ask the one question over, like if you have 200 items and you're like, I need to know the bottom of all 200 items, you could just say, I want array sprite B, and I could put 200 or just drop in an array of 200 IDs to a sprite, and I'm going to get back an array with 200 numbers in it that are going to correspond to those. So yeah. What else we got here? We have, so I kind of put usage. I try to put as much information in here as possible. Mouse commands, creating new ShellGame objects. So the recs are kind of self-explanatory. The music stuff, just very simple right now, but it's enough to get working. So for sound, you can say a new sound. You get a sound ID back. You can play that sound. I didn't do a repeat on it yet. I forgot actually, but it doesn't matter. It works good enough for right now. So it plays the sound object, and you can set a different sound file if you, for some reason, I don't know why you would want to, but like I didn't really want the ID that I was holding this specific sound. I wanted to be a different sound now. You can just load in a different sound, but realistically, you should load all the sounds with different IDs, and then you could just play the different IDs and leave them loaded into memory. That would be the way that would work. For music, you can do the same thing, but with the music, when you play it, right now I just have it looping continuously. It just loops. I forgot to add in the option. That's future stuff, like future work. But you just play. You can only play one music thing at once. So you just play the music by ID. You can swap out the file loaded for the ID again, but you could just load different music with different IDs. So you don't need to do that. You can set a playing music to pause. You don't put an ID because it's just an SDL2. It's just whatever that playing music was, that's the playing music. So you can set it to pause. You can resume it. You can halt it. And you can query it to see, is it paused right now or is it playing? And you can free it. Again, you don't really need to free it, and you don't really need to set a new music file. Once you've created it, you pretty much need to just play it, halt it, pause it, resume it, whatever. Yeah. So things that is missing from this is like drawing rectangles. I didn't implement that yet. Drawing rectangles, drawing filled rectangles, changing the volume, looping or not looping a sound. I didn't add those things in yet. So I'm sure there's lots of things missing. Wait. So, like I said, there is features missing, and you could go on and add features forever. But this at least gives you, like, you can make a game with it. You can do all kinds of fun stuff with it. And it's Like there's definitely enough there just to make simple games. If you're making really complicated games, you're probably not in Bash anyway. But you can kind of prototype or just have fun. Or if you don't know how to program outside of Bash and you've already been using Bash, like this is you can just play around with this, and it totally works. And you can do full screen and everything else. Again, I can't show that on the stream, but it does do it. And again, my original code was SDL3. I ported it to SDL2 from SDL3. So there will be an SDL3 version. I'm waiting on them to finish SDL3. It's not a problem with me using SDL3 as a backend. It's just the fact that it's not there yet, so I can't do it. And I'm sure there's bugs. Okay, so like I went down a rabbit hole with this. I was just like, can you do SDL from like the shell? Surely you can. And then it was like, how can you communicate? How can you do this interprocess communication, and how does it actually work? So that's why I have these like 5 different backends, and it was just like, how fast are they? How well do they work? Can you actually? Will this be fast enough to actually make some kind of simple game that functions? And the answer is yeah. I mean, like this super simple game here, definitely, but you could do something probably 8 times more complex than this and get away with it. When you get too complex, then you're gonna, you want your frame rate to, be reasonable. But with some of those tricks of the arrays and everything else, like you can do a lot of stuff, and a lot of things are done simple because I implemented these text objects for you. So you just need to say, I want the text to be this now. I want it to be anchored in this spot, and whatever it changes to, it'll always be there. So yeah, that's kind of a lot of information. Hopefully somebody will find it interesting and enjoy using it. But it is on GitHub right here, ShellGame. And, I'll probably make some videos showing how to make the yellow snow from scratch with it, and some other maybe simple things, and maybe clean some bugs up when I find them, and work on the documentation. I wrote all this documentation the other day. I'm sure there's spelling errors and everything else in it. Let's see. I'm not sure if I'm forgetting anything. But yeah, this was kind of a weird thing. Like I was working on 3D, and then I was working on this neural network thing, and I was working on this programming language, that I was trying to make this low-level programming language. And then I was just like wondering if you can make a game in Bash. And I actually don't know Bash very well. I mean, I just know basic things, how to do basic things. So I kind of, the other day I got my son's him out next to me with his MacBook, and we basically got this working on that because it was working in Bash with just the pipe. And so we found out what's going on, what's the compiling problems. Can we get this working in ZSH2? And we got basically everything working in ZSH and in Bash, except for the bit that can't work, which is the shared memory. So everything else does work. So that was kind of amazing as well to see that kind of like have all these different roadblocks there, and then kind of, we need to rewrite the shell script slightly differently because this doesn't work in ZSH, or it's written differently or something like that. But yeah. And I want to use the SDL3 because and again, the OpenGL is not implemented in Mac. It's like software rendered or something like that. So it's funny, his machine is much stronger than mine, but it is laggier and glitchier because I think SDL2 is slow in Apple Silicon because they're using Metal, and they didn't implement OpenGL. So I kind of want to see the SDL3 version running on his machine because it's probably should run very well, whereas it's slower. It still does okay, but it is slower on the graphical part, not the interprocess communication, but just the graphical drawing of it is not as good as the experience, because I think the OpenGL is just software mode in Mac. I think that's what's happening. Yeah. So if anybody has any questions, they'll just have to contact and let me know. I can't actually see if anybody's watching the stream. It looks like nobody is, or the thing's broken. I have no idea. So Anyway, I am on. Let me go back over here a second. So this, yeah, it looks like there's nobody even. Let me refresh it. Sure, working well. Yeah, maybe nobody cares. Um, but so I am on Twitch here as well, but again, on Twitch nobody cares either. And I am on X, and nobody really cares. I have 4 followers. I think I've been there since like last year. I'm really good on social media. Everybody knows me. 4 people know me. And you can hit me up there or on Blue Sky. Actually, funny enough, I have more. Oh, I just got another one. I went from 26 to 27. Yeah, cool. Um, Facebook, I don't have any friends. Nobody likes me. I haven't used Facebook that much, to be honest. I am in Aberdeen, so I tried to make this Aberdeen Nerds group. If anybody is in Aberdeen, and this picture is really rubbish. It's meant to look like this because if you're in Aberdeen, you know about the granite. There's like really nice granite all over the place. So if you kind of are into nerdy stuff in Aberdeen, yeah, let me know because anything that's like retro computers or retro gaming or programming or any development or generally, I mean, we go down there and we play like what is that, D&D, you know, all kinds of. My son's been playing D&D. I've been playing with him, so that's been pretty fun. Just general nerdy stuff. I can really get into it, but the picture here on Facebook is pretty rubbish. They blur it a lot, and yeah, hopefully SDL3 will be up and running. But I'm probably going to end it there. And yeah, I hope somebody watches this later and this is good, or maybe I've messed the stream up. Who knows? But I do have a local copy of this too, so I can re-upload it. But anyway, hope you enjoyed that one. Let me know if you have any questions, and I will see you in the next video. Bye. Or just